All right, so we are going to flip our notes a little bit. We're on to part two, regression models. So what your discovery activity that you did today was leading you into today's notes about regression models and scatter plots and regression models. And so that is why we were doing that. The hope is that when you do a discovery activity, it is your introduction to a new topic or a topic that you have some foundational knowledge of. The theory is when you see something for the second time, it's supposed to help it click. So the discovery activity was your first time seeing and doing. And then now we're going to do it in our notes and show it should make it click a little more. Does that make sense? Okay. There's a reason and rhyme to the craziness. So what if I have data but no scatter plot? What do? I make one, right? I make a scatter plot, which is what you did when you were doing your discovery activity. So we're going to go over how to do that. So the old notes should have been this, but we're going to now do example number 2 so that your notes are side by side. Are they side by side? Okay. Yes. All right. Cool. So we're going to be using the TI-84 method. So to start off with the TI-84, we're going to go over the steps to solve. What is the first step that it says on your paper? Reset our calculator. And how do we reset our calculator? Second plus 712. So here's my girl Sylvie. She's a little old, but I'm going to go through and I'm going to do second plus 712. And notice that she has now been cleared. Okay. So that's what you're going to do on yours. Anytime you pick up a calculator in the class, you're going to clear it because you don't know what anyone before you has been doing. Does that make sense? All right. So now we're going to enter our data. Just like you did on your discovery activity, we're going to enter our data by pressing stat. So we're going to go to stat. And we're going to go to edit. Once in stat edit, we're going to input our data. So we're inputting this table of information. And you want to put it exactly how it is. So before we do that, we're going to define what is our independent variable and what is our dependent variable. In this case, based on the problem we have here, our independent variable is going to be the age, and our dependent variable is going to be the heart rate. Okay, so this is going to be our L1, and this is going to be our L2. Okay, typically, if you only have 2 variable data, your L1 is going to be your independent, your L2 is going to be your dependent. Okay, so now I'm going to input all of my numbers, and you're going to do the same. If you do not practice doing this now, when it gets to the quizzes and tests over it, yep. All right. Okay, how do we do? So now that we've input our data, so we've gotten down to this part, L1, L2 were defined, we put them in. We're now going to use the shortcut. So in your notes, in your discovery activity, it had you press second y equals. We're just going to press y equals. The reason why we do that is because it's the shortcut to turning it on. So we're going to press y equals, and you see where it says plot 1? You're going to arrow up to plot 1 and press enter. You know that it's turned on because it'll turn black. If your plot 1 turns black, that means it has been turned on. Okay. Next, instead of us having to set our window, we're going to let the calculator set the window for us. So in your discovery activity, it has you use your domain and your range to create your window, correct? Y'all remember doing that? Here, we're going to just let the calculator do the work for us. So we're going to go to zoom and we're going to go to zoom stat because I want it to graph what I put in stat. Does that make sense? So we're going to go to zoom and we're going to go to where it says zoom stat. You either can arrow down to 9 or just press 9. And it should create the scatter plot. Was my scatter plot created? Okay. Is this clearly a good linear model? What is the linear correlation here, though? Negative. It's a negative linear correlation, which means that my slope should be negative. Make sense? All right. So now we're going to go on to the next part, which is to find the equation of the line. So the next part of your notes should be right underneath. Do you see them? So we're on to that. It says here, we're going to go back to stat. Make sure that we don't need to change any of our data. Was our data fine? Did anyone have any errors? Perfect. Now we're going to press, this part is no longer necessary because I think that they fixed this, so we don't have to do this anymore. I'm going to double check for you so you don't get embarrassed. Yeah, we're good. Go back. Okay. Back. So here, we're good to go. This part, we don't have to worry about anymore. So step 2 is not necessary because they updated the calculator and allows for you to not have to exit out to get there. You can, it doesn't make a difference though. All right, so once we're here, we're going to press stat and we're going to go to where it says calc. Do you see where it says calc? So we're going to arrow over to calc and we're creating a linear regression, a linear model, because we've already decided that this is a linear model, correct? So we're going to go to where it says linreg, ax plus b. Do we all see that? So we're going to press 4. And we've already defined our x was our L1, our y was our L2, and the frequent list doesn't matter. And you're going to now come down to where it says store regression equation. Okay? Storing your regression equation means that you want it to graph it for you. Okay? Is it necessary? No. Could you go graph it yourself? Yeah, but if I can make the calculator do it, why not make the calculator do it? Does that make sense? All right. There's a calculator update. So we don't have to press all of these buttons. We now can just press alpha. So you can press the alpha button, which is your green button. And then you're going to press trace. That says that terribly. Oh my God. Let's try that again. So we're pressing alpha. And then we're going to press trace. Okay. Do we see alpha? Do we see trace? This is going to ask you which equation do you want it to be? I'm going to let it be equation 1 because I have nothing in equation 1. Does that make sense? So I'm going to choose 1. And then I'm now going to arrow down and hit calculate. So it's going to do all the work for me and it's going to calculate my slope and what's the B? My y-intercept. Do I have the things that I need to write my equation? Yes. A is my slope. B is my y-intercept. So now I can write my equation of my line. Do we see that? So it says, what is the equation? We're going to round to the nearest 3 decimal places. Is that cool? So our equation is y equals, and I have negative, and we knew it was going to be negative, correct? 843 x plus 162095. Yes? And that would be our regression model. Okay? Because we told the calculator to graph it for us, it already puts it in y equals for us. So it's already put in for us, which means that when I go to graph, it's going to automatically graph it for me. We already did it. So if you click on your y equals, it was already put in there for us. And when you click on graph, it's already in. That's why we store it. Okay? Yes? All right. It says, what is the slope of the regression line and what does it mean in context of the problem? So when you're describing the slope of the regression line, remember, your m equals the change in your y over the change in your x. What did our y represent? The target heart rate, right? The beats per minute. So our heart rate, So it's a change in our beats per minute. And our delta X represents what? Age, which is measured in years. So therefore, when we're describing our slope, these are the units of our slope, beats per minute per year. Does that make sense? Okay, when you're describing it, it's beats per minute per year of age, right? Probably. So our slope is, there we go, negative 0.843 beats per minute per year of age. Does that make sense? Okay. So as long as you remember what the numerator represents and what the denominator represents, then you have the units that describe what your slope means. Okay. Your dependent variable axis of intercept, that's just the longest way of saying what is your y-intercept. Okay. All it's asking you for is your y-intercept. Okay. Your y-intercept is when your function equals, when x equals 0. Do you remember that? So we're looking for 0, comma, our b value. And what is ours? 162, right? Okay. So we know that b equals 162.095. And this is beats per minute. Because what is your y defined by? Beats per minute. Now, what does that 0 mean, though? That's the age, right? Your 0 is your x, and x represents what? Age. So therefore, this is the beats per minute of what? Of what? Of a newborn. So this is the beats per minute of a newborn, of a 0-year-old. Because that's x equals 0. Does that make sense? That's why we define what our independent variable is and what our dependent variable is, so we can interpret it. Okay? All right, it says use the equation of the regression line to estimate the target pulse rate during moderate intensity activity for a person who is 21 years old. Show the work that leads to the answer. So we're looking for someone who is how old? 21. So is that our x or our y? It's our x because it's in years. You see how units matter? So we're looking for if x equals 21, what is the output? What does y equal? Does that make sense? So there are a couple ways of doing it in the calculator. Let's talk about those ways. So we're looking for y equals, correct? All right, let's talk about the ways. So since I have the graph up, I'll start with the graphical way. Once you've created your graph, you can analyze it, okay? To analyze your graph while it's here, you press trace. Okay? And once you press trace, I'm sorry, I have to press second trace. Don't press trace, press second trace. And you see what says value? You can type in whatever x value you want. It even says x equals, and our x equals what? 21. And I press enter, and it's going to tell me the value of what x equals. Do we see that? Okay. So that's option number 1. How does option number 1 feel? Easy, doable, right? Okay. The next option is you can go back to your calculator page. When you go back to the calculator page, you press second mode. That takes you back to the calculator page. Here, do y'all remember when we pressed alpha trace and we saved our equation as number 1? I can now say, okay, at number 1, I need you to tell me what is 21. And it's going to tell me that the value at 21 is 144. Does it matter which way you do it? No. Pick your poison. Okay? You can use the graph or you can use function notation on the calculator mode. Did they both give us the same thing? Yes. So if I'm a 21-year-old and I'm working out intensely, I should expect a beats per minute of, there we go, 144.395 beats per minute. Was that terrible? No, it wasn't. And I know you wanted it to be, but it wasn't. Okay. You are capable of it. All right. Do you see that this is essentially what you were doing in your discovery activity? If you follow the steps. Okay. All right. So that is method number 1. We will do method number 2 and then take our quiz tomorrow.